So now we are going to see how fire sprinklers operate. The sprinklers, how it are operating, as I told you before, this it has been used. You see that there's no glass inside, and there's no plug, as you can see. But this one it has. So for the first stage, before it cannot break itself like this when it is hanging on the pipe. The factor to break these kind of sprinklers, it is the fire, or it have to be heat. If the heat it is coming, this metal will absorb temperature or heat, and it will melt or cause this liquid inside the bubble, which is bubble. It will expand and it breaks, and then the pressure which is here, it will push the plug and goes out directly. And that it will be caused by, it will depend on the kind of sprinkler head. If it is yellow, if it is red, you will see according to the color code we have on this kind of sprinklers. So the plug, then it goes out by pressure. The pressure comes from the water main or the pipeline, which is or have already installed. So we have a design principles of sprinkler system. To design the sprinkler system, we have to refer to three main objects or three main purposes. So we have to know the spacing of the sprinklers. How to know that one? We have to know the height from the ceiling and where the water will be sprayed, which is the type of sprinkler and the area of sprinklers, where are going to be sprayed on the ground or on the floor. And the height of ceiling, of course, that will be one of the cause to make the design of the sprinkler system. As you see on the board or the flat, you can hear the discharge pattern for conventional system. For sure, you cannot find the water which will be sprayed in the right angle or in the right line, straight line. It has to be, when water is spraying, it goes wherever it wants, like as I show these pictures. So here we have the conventional sprinkler spacing. It may be seen like a circumference having the diameter on all diameter are equal in all direction, but in a real sense you cannot find that one. You may find the sprinkler when it is in a corridor or water will not spray as a cycle. So it will be sprayed like over because of the walls which are side and side. So here we have a table which is illustrating risk categories and normal pressure to be applied in the system. When we have a risk category, which is the light hazard, we will have the flow rate of 225 liters per minute, and in that system we're having the normal pressure, which is 2.2 bars. And if you have a risk category of ordinary hazard group 1, we have in the pipeline the flow rate of 375 or 540 liters per minute. That one, it will involve the pressure in the pipe of 1 bar or 0.7 bar. If we have ordinary hazard group 2, there we find the flow rate of 725 or 1,000, which will be having the pressure, normal pressure of 1.4 bar or 1 bar respectively. And you have also a kind of ordinary hazard group 3. This kind of risk category, it will be involving the rate flow of 1,100 liters per minute. Another one, 1,350. Those will be corresponding to the pressure normal, which is the 1.7 bar and 1.4 bar respectively. And also we will have another kind of risk category of ordinary hazard group 3S, which is involving the rate flow of 1,800, which is corresponding to 2 bars of normal pressure, and another kind of flow rate 2,100, which will be having a normal pressure of 1.5 normal pressure bars. Here we have a table which showing there how to install our sprinklers according to the height of the ceiling. And when we have an obstacle like beam, we have to consider it. And also the maximum spacing between N2 smoking or heat detector measured across the beams. If you have 6 meters or less from the floor up to the ceiling, we have to consider the maximum spacing of those sprinklers, 5 meters or 3.8 meters. It will depend on the depth of the beam. Those 5 meters or 3 meters spacing of the sprinklers heads. If you have more than 6 meters, there we will have also the maximum spacing between sprinklers, 5 meters or 3.8 meters, which means if you explain a little bit on this law, showing that the 6 meter height from the floor up to the ceiling will give the maximum spacing between 2 sprinkler heads of 5 meters and or 3.8 meters. If I don't have any beam between my 2 sprinkler heads, I will immediately take 5 meters as the spacing between 2 sprinkler heads. And also we shall have, if you have the 3 meters or less of height from the floor up to the ceiling, there you will take the spacing between 2 sprinkler heads of 2.3 meters or 1.3 meters. And also 4 meters from the ceiling, this corresponds to the 2.8 meters or 2 meters of spacing between those two sprinkler heads. Where if you have 5 meters of height, this corresponds to 3 meters or 2.3 meters of spacing distance. And if you have greater than 6 meters, there will take the spacing of 3.3 meters or 2.5 meters. Now, to install, we will need the source. Where is the source of our system? Our system will start from the main, and we will install the back pressure valve from the main, and we also install the stop valve, and also we have to install the alarm valve, which will be communicating with the automatic valve, which will be open when there is a fire inside the building. And also, in the system, you have to have a high pressure, which will be work to push the plug out when the fire is there, it happens. Meaning that when we don't have a source of pressure, we may have the tank which is there to serve as a source of pressure. That tank is called pressure tank. The pressure tank, it is also having the bubble tube, which will be graduated, showing the level, the level of water which is inside the system or inside the tank. That one, it will help the system to get the pressure, which will be involving in spraying water when the sprinkler has been broken. It's bubbles, it's glass. For this session, it was theoretical part. Later on, we're going to have the practical part showing all we have seen in this theoretical part. This one, it will be involving some many tools, whereby I will going to explain each and everything which will help me to get this system operate. Thank you for your attention.